ASTRA's recovery system is back at it again with some more shock testing with the guillotine. This of course is all for the rocket that we're building, which will go to space. But before we can get a rocket to space, we first have to test it and verify it on the Earth. We're testing the structural integrity of the parachute system, which includes the Drogue mount points and the main parachute mount points, in order to see if we have the strength to withstand the deployment of the parachutes. Both of these tests didn't go quite as planned the last time we tested.
Nobody withstands the machine.
So we've made some modifications that hopefully will do the job this time.
Hold on a second. Have you not watched the first video? If not, then what are you doing? Spoilers! You can find a link to part 1 of the testing campaign in the upper right hand corner. It certainly was, let's just say, interesting. Don't worry, I'll wait.
The first part we tested was the Drogue mount point on the parachute system, and unfortunately this test failed last time. In order to strengthen the system in this area, we've actually switched from using our L mounting brackets to T mounting brackets. And basically what this is doing is it's going to be better transmitting the forces through the structure of the part,
And it's going to prevent us from having the same failure that we had last time, at least theoretically.
The L brackets were not strong enough last time and were clearly bending at the angle of the L, where it's a lot easier to actually cause deformation and eventually structural failure. So this time we have these T brackets, which will, as I said before, transmit the forces better, but there's no real weak point on them which can easily bend, and that's going to be the critical thing that's going to allow this system to be a bit stronger than the last one. We also had a failure in the main deployment testing. However, we suspect that this failure was largely due to the fact that the box of the recovery system was broken before we actually tested this because of the previous Drogue deployment testing.
We hope that our system will be strong enough to survive the Drogue shock deployment test, and then it'll actually be able to be strong enough to survive the main deployment test. So we didn't really make any major modifications to the system in this particular area.
We also made some slight improvements to the overall setup of the guillotine. We've added some extra carabiners to the attachment points just to make sure that any failures happen, they will happen at the point we're actually trying to test. We've also definitely overdone the connection of the recovery bay onto the mounting plate with many more screws. We have 3 in each of the attachment points, which now doubles the connection that it has with that mounting plate. If you remember back to the first test, this was an issue in the first drop as we actually ripped the whole test piece right out of the mounting plate. And that caused a lot of damage before our testing even started. So we want to definitely avoid this in the next round of testing. So with all of those changes, we set up the entire stand again. This time we said, no, we're not going to test at a lower weight. We're just going to go all the way at the start because, hey, that's how it works in real life. So with 25 kilograms on the rail, we hoisted the weight up to the top height and got ready to test our first system, which is the Drogue attachment point. Will it survive? 3, 2, 1.
Okay, so that didn't look so good. But actually, if you look closely, the system actually did survive. The problem actually was with the attachment method that we were using to the main line. We're actually using a carabiner to do that, but one thing that's important about a carabiner is that they only work if they're actually closed, which in this case, it was not. Okay, so that's our silly mistake of the day. With the replacement of the carabiner and the resetting of the system, we were able to get a much better test for the Drogue deployment shock test. So, were we able to make it?
A few moments later.
Go, second try. 3, 2, 1.
I never doubted you for a second.
Overall, this test was actually really successful. We were able to withstand the force of the guillotine dropping and come out alive.
That one sustained it quite good, I would say. We do not have any ripping out of any of those nuts. The T also withstands.
However, there was a little bit of minor bending, but this isn't totally out of the ordinary because We really only need the thing to survive for just that one deployment. So if there's some things that are bent a little bit, not too big of a deal.
We could now do the main test
Yeah, I would do that first.
first, and then we can iterate.
Because we need the bottom box intact, I think, to properly do that test.
Definitely be beneficial.
And this is realistic, right? One Drogue deployment, it deforms a little bit, and then it should survive the main.
Yeah.
And the important stuff is that the Drogue deployment doesn't lead to deformation that would result in the deployment mechanism of the main to not work.
After being satisfied with those results, we decided to reset the system and get ready for that main deployment test. So here we're actually going to be testing on the very top of the recovery system, where we have another carabiner that's on the base of the whole system itself. In the last test, this failed in a pretty major way, basically tearing apart the entire system. But we suspect a lot of that is because the system itself was actually not intact before we tested it. So we'll see if that's actually the truth. After a quick reset, we were back on the stand and ready to test. So it looks like things didn't quite go according to plan, and maybe we should have made some modifications before we went ahead with this test.
You can see we basically sheared that aluminum profile right there.
Yes, most probably.
The system did fail in a slightly different way though. Instead of having the entire system ripped apart like it was last time, we have basically the shearing of this beam which we placed that carabiner on for the main deployment test. Because of the way the forces are distributed on the beam, we're basically putting it in the worst situation it could possibly be in, and that's essentially what's leading to this shear. So we definitely need to consider a redesign before we come back and test the system again. But all hope was not lost. We still had some extra things that we wanted to test for this day. One of the last things that we need to test is the release mechanism that we're going to use in order to release the Drogue line that will pull the main chute out of its canister.
Okay, so the idea here is to have this piece to attach the Drogue mount to the maker beam, and this will be secured in here by some sort of spring bolt combination, right? And this again is a secured little splint over here. And then this whole thing goes to the maker beam, so to our main structure. And on here there's the Drogue chute attached here. And then when we want to release the Drogue, to release the main chute, some sort of step motor or servo motor pulls out the splint, so that this comes off, and this can fly away with the Drogue chute, basically, you know. And then it pulls out the main parachute.
So basically the splint, can we show the splint again?
This one?
Yeah, so this guy right here is going to be pulled out by the servo.
Yes.
And then that's going to be what allows the spring mount to activate and basically send this thing free.
Exactly.
Basically, this pin has to be able to survive the shock of the Drogue deployment forces while also not bending or deforming at all, because if it does bend or deform, that pin will not actually be able to release the parachute in the end.
So I would say we shouldn't shock that to the full load, because we will not get anything out of that. Because I would say instantly will rip. I would say we want to approach the point where it actually is failing. So we should go for a lower shock first, and afterwards incrementally increase that, and then try to decide the limit that it can actually endure. I'm more than skeptical.
Yeah.
More than skeptical.
It is definitely not made for structural tests. It was made to be a demonstrator to print that stuff.
So the interesting thing about this release mechanism is that we're actually building it out of PLA, which is the material we use for 3D printing. And 3D printing materials aren't exactly known for their structural strength. So this is why there was a bit of an internal debate as to whether this system would actually be effective. With this in mind, we decided we want to start with a very low shock at the start, just to make sure that everything was working properly, and essentially test it until it failed, because we suspected that it would. So with the first small shock load tested and working just fine, we decided to double up and go for a little bit more. All right, things are looking a little bit better on this system than we thought. Why not go a little higher?
I mean, we did some FEM analysis of this part with PLA as a material, which did withstand a load of 3,000 newtons.
I'm more than skeptical.
So it turns out that our Drogue release mechanism is actually a lot stronger than we suspected. Maybe we should be putting more faith into Leon's FEM analysis, which said that it would survive these shock loads anyway. So it turns out that we actually maxed out the guillotine in this last test, so we actually have to make a couple of modifications in order to get ready for an even bigger test, because we want to see this thing fail. We want to know where the breaking point is. So our theory is that if we make the line longer that's connecting the Drogue release mechanism to the weight at the bottom, we can actually have a longer acceleration phase, and then we'll get a bigger shock. So after selecting the longest line that's possible with the guillotine that we're using, we reset the system, seeing if it would actually break finally this time. So it turns out that Leon made a really effective system here. With just a little bit of PLA and aluminum, we're actually able to make a really effective release mechanism. We even went into the lab and tested that release after we did the shock testing, and it worked like a charm.
Okay, 3, 2, 1.
Oh, nice. So we're glad that we're able to end this second round of testing with mostly successes. There are just a few outstanding things. After some review of the high-speed footage for the Drogue deployment test, we actually realized that we didn't quite hit the 3 kilonewtons that we were looking for. Instead, it ended up being about just 2.1 kilonewtons. So we will have to come back and test that again to make sure it can actually go all the way up to the 3 kilonewtons we need. And then secondly, of course, we still have that main deployment test, which is not quite going the way we want it to. Even with just the 2.1 kilonewtons, we still had that failure with the beam shearing. So we definitely need to redesign this system so it can handle a bit more. Overall, I would say it's a pretty successful day of testing though, and we're definitely getting closer to our final design for the system. If you're enjoying watching this testing campaign, be sure to give us a like. And remember, to expand your horizons. I wanna be the best in the game, invest in my name, check no restraints, I'm obsessed with the pain, I ingest, I retain, assess and I change, possessed by the thought I'll be free one day from society's restraints, money, clout, and fame.